Okay. Yeah, so really interesting talk. I'm just going to make one comment right off the bat, which is that harvest mechanism in ACTAR, where they automatically throw the chunk into DM, that's often turned off.
I will
Because
agree that a lot of these mechanisms have switches associated with them so that sometimes they're used and sometimes they're not.
Yeah.
But what I wanted to do is show what is possible in these architectures.
Yeah, it's an interesting question. I did some work where I had to turn it off or it wouldn't replicate human data. So, that relates to some of the papers, rock, scissors work that Christian and I did. So we have a few comments here. One is, I'm just going to say we probably need a lot more terms for metadata because everybody, so maybe we could do, yeah, metadata is something we need more terminology for. Okay, good. How much do you think it is a problem? Because I had a student who just recently did SOAR ACTAR and Python ACTAR and looking at the similarities and differences right in the code, like down to the code. Actually, Frank Ritter was the external for that, if he's out there. So how much do you think, how much do you think it's a problem that it's hard to go into the code and pull out the cognitive differences or the sort of theoretical differences from the code?
Well, my hope is that people don't have to go into the code. Now, there are like 5 different versions of ACTAR. There is an ACTAR manual that is 500 pages. And that itself is I give a lot of credit to the authors of that, but that allows you to get an idea of it. I think we try to write about SOAR at an abstract enough level and a sufficient level and provide tutorials and things like that, as does the ACTAR group. So you don't have to look at the code. I personally have never looked at the code of the current SOAR system in order to understand it. So I'm hoping that we can provide those abstractions by the way we document the systems.
Okay, another question. And we'll just maybe fold into the discussion at this point. But so this is the question, like the part of the thing you mentioned with SOAR, where it does the impasse and the sort of problem solving, like how much, it seems like the sort of Newell's problem search space stuff is sort of in the architecture of SOAR, whereas it's not in the ACTAR architecture, but it could be built in the ACTAR architecture. And is that a difference or non-difference?
So the key aspect of SOAR that supports internal search, my view, is that we do have impasses that arise when we can't get a retrieval from procedural memory, which means in SOAR, we can't get a single operator proposed. And so that then leads us to a substate in which we do additional meta reasoning, but it's using the same mechanisms of procedural memory and declarative memory and working memory in order to do that. So the fact that we can have a representation of the state at the top level, but then we can make copies of that representation of the state in the substate is really key to being able to do a look-ahead search. That would be much more challenging to do in ACTAR, and I don't want to say it can't be done, because I think the way you would do it in ACTAR, which is the way you do a lot of things in ACTAR, is you depend on the fact that the chunks in the buffers are getting pushed into declarative memory and that it's easy to get them back. And so instead of depending on everything being in working memory, you will be having things being pushed back into declarative memory and then having to retrieve them in the future. To do that might be a little tricky, but that I think will lead you to the kind of human problem solving you see that is not like breadth first search. So there's something called progressive deepening, which Newell and Simon identified, which is that you do a forward search, and then when you get to the end, you actually are not able to go back to the intermediate states so much as go back to that first state and take another path down, which ironically, I think it's ironic, is the way many of the new probabilistic search algorithms work, is they go back to that first state and then re-explore. So it just turns out that because of memory issues, that's an efficient way to do it.
Okay, let's see. I'm sort of just getting a feeling of these questions. Okay, I'm just going to do a sort of combination thing here. To what extent, and maybe at this point we'll start throwing it open to the other panelists. To what extent do you think, like, let's take the Actar SOAR example. So there's some underlying differences, but a lot of underlying similarities. But, you know, several of the panelists brought up things earlier, such as, you know, separating slot contents and slot values was one. Another one was using transformer type representations, which I interpret to be that the chunks know a bit about each other. The chunks are informed by their past history with other chunks, which is similar to the holographic. But to what extent, like, or the reinforcement learning, like, to what extent should we be asking questions sort of pitched at a higher level, or the specific Actar SOAR level versus, you know, we're looking for the right reinforcement algorithm, but maybe these underlying like details, like you're talking about, really make a difference in terms of how that works. That's a complicated question, but what do you think?
Well, I think we're trying to answer different questions. And so I think we want to have different levels of analysis. And so I think that's the number one thing, is that that there's not just one level of analysis. You know, what I did with Actar and SOAR is not appropriate to take this higher level view of asking questions about, can you get unification? And so I think Marcin's, you know, approach and Paul's approach, you know, in that we need to have these different approaches. We need to look at commonalities and regularities from different perspectives, and not just in terms of what I was doing, is how these architectures turn over. So I think it's really important to have multiple perspectives.
Okay, so I'll just put it on the other panelists too, to jump in anytime with this. Like, what do you think? Multiple perspectives, or do we need a unified account from bottom to top, or?
So there was also another question on the chat regarding the parameters thrown at modules or something like that. I lost it. My take on the issue, whether something is to be expected or even valued as something that we want to have in the architecture, should be evaluated not only in view of how it contributes to unification, but also in terms of other theoretical virtues. So you might want to see how it coheres with other things, or whether these parameters are just parts of the code. It allows it to work, but it's not really part of the official specification. I think this is something that Rick Cooper has written about SOAR, that only whatever is in the code, it's not yet a theory. We should understand what it's actually doing. So it may not be necessarily a bad thing when you have lots of details in different places, unless it's not ad hoc. If you have a principle that actually tells you that this is simply the data that you observe, so the things that, for example, human subjects would interact with, so they cannot be predicted by the theory itself, because this is, even people cannot predict it, but how they deal with the data should be a part of the theory. So I think this is just stated generally. We cannot answer the question. We have to understand what place it is, what context it is, and what theoretical virtues we want to have. So unification is just one. We might want to have the ability, the breadth of application as well, but we want to have efficiency, which is a different thing. I think Paul's list of lots of these abilities, these were absolutely virtuous. And of course, conversely, you could have vices that you want to totally avoid if you're developing such a common model, or that would be based on or distilled from, because I think it's still a very open question what you want to do with the common view of the similarities here.
So I guess I would give a fairly complex answer to your question, Rob, because I think it's a complex question. In terms of analysis, ultimately what you hope is that a field has a set of analysis tools that are at least compatible with each other, that aren't conflicting, but they might be at different levels. There might be other aspects of it. So I think what we're seeing today was in fact 3 different levels of analysis to some extent. Whether they're all compatible at this point or not is a separate question. In terms of actually building intelligent systems, general intelligence or whatever, if we're talking about building models of a single system, like models of an individual human, then ideally you coalesce on one single model, though again, there may be multiple levels of description of it and stuff. But if we're talking about the space of all possible intelligent systems, then that's a much broader target. And so there may be many different ways of achieving different forms of intelligence. And so you get diversity not by having different models of the same thing, which ultimately you'd like to get away from, unless again, they're just different perspectives on it, to different kinds of intelligent systems. So the kind of thing I'm doing is partly to understand human-like cognitive architectures, which is sort of what I most care about, but it's also to help understand the space of possible intelligent systems.
Okay, that's a good point. So what do you think about, because I want to bring this back. So Marcin, a few people have mentioned Rick Cooper, who wrote a paper about this referencing SOAR. And so his point was very, I feel like very psychology based. Like how do you, and some of the comments have been very psychology based, like how do you evaluate this against data? How do you evaluate against data? But there's the AI question too, right? Like, which is humans are generally intelligent. So I don't know if some of you would like to comment on this difference between sort of psychology takes on human-like intelligence, which is very much like fitting data, and the theory is all about fitting data, versus the AI takes on human-like intelligence, which is more about performance and so on.
Well, so in my terms, it's a question of what criteria you're using for guiding and evaluating. So for example, AI tends to be concerned, or at least traditionally was concerned about proofs of correctness and accuracy in terms of optimality rather than in terms of match to human data. When we talk about the common model and we're trying to talk about, again, human-like architectures, we're trying to combine the criteria from those 2 fields, but realizing that there are some incompatibilities and some trade-offs. And so we may not be able to completely achieve the criteria of either field, but we're looking for some kind of reasonable trade-off between them that lets us learn and contribute to both. At least that's kind of how I view the combination.
Any other comments?
Yeah, I think there is a more general point in Cooper's work on SOAR there. I've recently looked at the problem of replicability of computational neuroscience, which is really, there are very few attempts to do that, but it turns out that it's immensely difficult, especially if you want to do so-called conceptual replication. So using a different software and different platform, and just by reading the paper, because papers are totally incomplete. They do not provide you the theory. And I think that was the point. Provide the theory in a paper. Do not relegate the theory into the code or the comment section of the code, because that's not readable. Especially with the neuroscientific models, reviewers were getting 1 gigabyte file, and that was a zipped file, and they were supposed to go through all the data and see all the comments. And I mean, nobody is able to referee such a monster. So Journal of Neuroscience banned doing that. And I think there was a reason. And I think that's a perfectly reasonable strategy. If you want to express your theory, you should be able to do that in a paper and not in the non-refereed attachment, which is 1 gigabyte large. So the idea here is that you should specify it clearly so that such analysis as John's would be available. And going for, if you compare the situation with biological life sciences, there are several formalisms available there for bioinformatics that are used to express various models. They help with replication. Of course, those formalisms constrain how you can do things, so they have to evolve over time, but they allow you to express in a common format. So I think this is the one way it helped in biological domain to work with it. So I think this is a very important issue. Whether you're doing AI or not, you're still doing theory. So what you're doing, what you're doing should be understandable. It should be communicable without reading all the minutiae, all the specific small parameters somewhere hidden out there. So I think this is a very important thing, that it should be understandable in some format, but it's very difficult to come up with a format. Maybe it should relate to this kind of distinctions like symmetric, asymmetric. I'm not sure. This is a very open question. We don't have it yet.
It's an interesting, John.
So I want to make 2 points, and that a little bit long, but one of the things that's come up in the chat related to this is whether or not SOAR and ACT-R are sort of at a local maximum or something, and that's because they share a lot of these things, and then they sort of go off onto the side a little bit, and it makes me wonder if that's going to be true for other architectures as well. Is that it might not that we all come together in a common architecture that we can get that's more specific than what we have, and that we actually will have these ontologies of architectures which show different commonalities, but they also show different branches in terms of underlying assumptions. And part of that might be, what do we assume is available? So one very specific thing is, you could argue that the reason why working memory in ACT-R has to be small is because we're mapping it onto the brain, and that the brain technology, the way we think it works, cannot handle the arbitrary data structures that we have in SOAR. So SOAR lives in a slightly different world than ACT-R in terms of that. And I also think that that's what we should expect going forward when we talk about AI versus cognitive modeling. AI systems are going to be able to have different underlying technologies, different kinds of embodiments, different kinds of sensors, different ways they're interacting with the world. And it might not be that the human cognitive architecture is the right thing for that. And as Randy was pointing out, if you look at these deep networks, they're taking a different approach to solving some of these problems in terms of just having a flow through to get to an answer as opposed to a cycle through. And so these different kinds of approaches might be better for different agents in different environments with different embodiments. And it is possible, so this is the very negative view of the world, is that trying to replicate human ways of thinking in AI systems, it's fun, it teaches us a lot about humans, but that might not be what we want to use in AI systems down the road. But don't tell that to my funders, okay? However, I also think that having AI systems that think like humans, especially when we do theory of mind, might be extremely useful. So there's these different constraints on what do we want these systems to do. And that might lead us to different parts of the space. And what's cool about what Paul's doing is he's trying to give us a view of what this possible space is and what the dimensions are. Is that right, Paul?
Yes.
Ha
Okay, that's it, just yes?
Simple answer is yes. No, I can't claim it's exhaustive or that I have all the dimensions of it, but to some extent, I'm trying to understand the space of technologies. That's not the space of agents, but maybe that's a development that, or the different kinds of intelligences, but that might come out of it at some point down the line.
Yeah, okay, so do you think that this is a main feature of the Common Model project, is sort of coming up with characterizations that can be applied to this field? And I'm also going to throw in, like, do we want the code in there? Like, I kind of do want to see the code, right? I mean, if somebody's making claims, I want to see it. I mean, I want to see it not be crummy, and I want to see it run when I push a button. But, you know,
well, yeah, I think that we want to be able to have replication. And so that means, but I want to be very careful about any promises I make about the examinability of the underlying code in terms of the code that runs SOAR, for example. So SOAR is written in C++ and C, and which is a lost art. And ACT-R is written in 5 different, I mean, there's a Python version, there's a C++ version, there's a Lisp version.
There's 2 Python versions.
There's 2 Python versions. There might be more. Maybe there, and there's a version. Yeah, so I don't know that we want to say that we have to be able to inspect that lower level, but it would be nice if a model that runs in ACT-R 7.2.3, whatever is the current version, runs in another version of ACT-R. I think that's a challenge for ACT-R field, is that with all these different versions, I would find it surprising that a version that runs in Python ACT-R runs in Lisp ACT-R. I mean, I don't know your community, but I can't believe that's what's going on there. People are rewriting these in these other languages for a good reason, so that they can muck with them. So I mean, they can explore the space of ACT-R-like architectures. So I just have to believe that there might not be cross-compatibility, which is, I'm sorry, this is getting way far afield from common model issues, but going back to that, I think a real possibility is there is not one common model. I mean, it might be one common model that is related to architectures that try to be very faithful to how how we model human cognition, but we might have variants along the way for specific differences in embodiment and things like that. I hope that one that we've tried to target is a really important one, and that we can get more depth into that than we have. But there might be these a whole collection of them, or sort of a hierarchy of them.
Do you think this, just all the panelists, do you think it's possible to have a common model meta code or common model meta model so that it could be specified, and then you could say, I'm going to take this and put it in ACT-R because I can. I'm going to put this in SOAR because I can, and then C sort of separate out, you know, the common model elements from the, you know, the fine differences in the underlying architectures? Because probably you could put that in a lot of architectures, I'm guessing. But what do you think? Like,
well, I think it's right now it's fairly unrealistic unless the common model specification would be rich enough informationally to be so that you could produce code from it. Right now it's fairly abstract, and But if you could, I mean, I could imagine lots of scenarios like the one that it produces some dummy structures filled with default values, and maybe those default values are somehow shared or something like that. Maybe it could work, and then you could compare it like this. There was yet another way of looking at problem of replication. I think it was in Topics in 2012. Adiman and French proposed that there should be some freely available architectures available online for people to work with, so that you wouldn't have to install it. So I think it's like the early version of Jupyter, not the notebook or something like that. And people are doing that, so that helps a lot if you can, if you don't have to install exactly the same 0.7, 0.773 plus the extension with some exotic versions on some. So if you can, and I think the AI world is doing that with lots of ways of standardizing, running Python versions and things like that. So I think it's going to happen, and it's going to translate in some way also to more academic research from business applications of that.
Okay. Okay, here's a question. I'll just pull out a question from my questions that I made up beforehand. Can anybody think of like, it's sort of fuzzy whether something fits common model or not. Like you can go right down in the details like John did, compare things. But just, can anybody think of a cognitive architecture? So not a deep network, you know, that just runs end to end, but a cognitive cycle type architecture that that would be like not common model. Somebody would look at it and go, oh no, that's not like, to what extent does the common model capture the sort of feeling of the field?
So Society of Minds does not fit with the common model.
Society of Minds, so Marvin Minsky.
And I think it will be a challenge for us to integrate in Clarion, but because it's trying to match two levels, what I would think of processing. I mean, I think what we would end up doing is taking a subset of Clarion and mapping it onto the common model. But I'm not sure, haven't tried to do that because it's just got some different kinds of goals. I think LIDA, if you package it right and you consolidate what are many modules in LIDA into something like procedural memory, there's a chance of doing it. But I think architectures that are three-tiered, where there's a separate planning component, and then an execution component, and so those are going to be more challenging to make compatible with the common model. But Paul probably has thought about this more than I have, so I should be quiet.
I don't know about more so, but I mean, I think this is exactly one of the kinds of questions we want to ask and ultimately answer with respect to some of the things that that John described. So Clarion, to some extent, I mean, in the common model, it merges together data and metadata. And John and I do have somewhat different notions of what that distinction is about. But in effect, Clarion separates those two into different modules, which does make it more difficult to figure out how to. So it would be different, I think, than the common model, but at a more abstract level, there may be some commonality. LIDA, a few of us were discussing a couple of days ago, LIDA has so many boxes, but is it possible to group those boxes in such a way that we can understand better the relationship to the common model? And does that give us the ability to do the kinds of things John was just doing to understand, okay, how does LIDA differ from the common model and the architectures that fit it more easily? Or are there fundamental differences that are really important? With respect to things like 3T architectures, it all depends on how you implement the planner. So if it's implemented in the way described in John's talk and in my talk, then it does fit within the common model once the common model is extended to include reflection of some sort. And depending on how that extension goes, which allows planning, the ones with separate modules for it may or may not fit into it very well. But given that the common model doesn't yet, it covers two levels, that kind of the reactive and the deliberative or sequence levels, but it doesn't cover the planning aspect of 3T architectures at this point. So there's a lot of interesting things that could come out from trying to do such analyses, but I can't say we've gotten very far with very many of them. I mean, there are a number of members of the community that have gone out, and so we see analyses for EPIC and for some other architectures in terms of the common model, which are doing some of that. But there are a bunch of others that we just, no one's really looked at it in seriously yet.
I mean, one of the things that came out of my talk or my work continually come out is this identification of how data, metadata, and module interactions seem to be these three separate things, at least in these architectures. And so I'd be interested, like, for example, Pat Langley and his architectures, do his architectures have these same distinctions, which is more general than the common model? And so I think that's one of the interesting things I would hope is that we can have distinctions about architectures, and this is, also of course related to Paul's analyses, that are not all down to the level of trying to correspond to the common model, but have some of the properties that we have found in architectures like SOAR and ACTAR and Sigma, in terms of, at least I think, how they represent data, task data, metadata, and communication data.
Okay. Well, we're getting to 1 o'clock, so I just.
Can I just add one thing to what John just said?
Yeah.
I mean, just as an example, John and I have been having various discussions about this topic, including what exactly data and metadata is and how they relate, as well as what module metadata is. I've been trying to argue, for example, that there's a larger class of architecturally detected situations that includes what he talks about in terms of module data, but also includes emotional appraisals and other kinds of things. And we ought to be thinking in terms of those kinds. And we also need to distinguish the kind of quantitative metadata we've been talking about associated with data versus data at the meta level. So there are all sorts of interesting things you can get into, and we've barely just kind of tapped the surface of these kinds of discussions.
Yeah, that's true. And there's lots of people built, like I was doing a emotional metadata for ACTAR, and sticking it in Python ACTAR. And there's other add-ons and things that people do that aren't part of the official story as well, like blending, for example, that Christian has used quite a bit. Yeah, okay, so I guess, does anybody have anything more? Everybody's okay. So I think, thank you to John to organizing this, and maybe he wants to say a few conference ending words. I'm not sure.
Well, I want to thank all the organizers. This year I was brilliant in that instead of saying I'm going to lead all the sessions myself, I got the organizers, the session organizers to do it, and they've done a fabulous job. And so I want to thank all them. I also want to thank all the speakers. This has been a tremendous week. I've learned a lot, and I hope you have. And I want, I want to do it again. So we'll do it again next year. Part of the way we do it is it's invitation only, but I take in input as terms of who we invite. And we also don't roll people over from year to year. So I'm the only speaker who spoke last year. And that's because last year I gave a talk on Introduction to Cognitive Architecture. So I thought I could give a content one this year. But I will not talk next year. Paul will not talk next year. But we will want to open it up and increase the breadth of what we consider in this. And I thought it was really cool to have the cognitive neuro talks, which we've only seen a little bit of the past. And I think we just have to engage across disciplines more in terms of having cognitive architecture grow as a community. So I hope that, I mean, another community that's associated with this is Advances in Cognitive Systems, which you can find on the web, is a conference, and we do a lot of cognitive architecture work there, sometimes with cognitive science, not so much at AAAI, but I'm hoping we can continue to build this. And I want to give a little shout out to Rob. Do you want to say a little bit about what's going on? Just a little bit about the work you've done at your institution?
With the Common Model Bulletin?
Yeah.
Yeah. So I put a link, which is, I'll put it in the chat. Let me get it. So we started creating essentially what is effectively a journal. So it's open, using open source journal software, which is made available to me. Yeah, we started just by posting the all of the common model discussions, which was 3 AAAI sessions spaced apart. And I'm not sure where this is going. It's a little bit of a strange thing to, anyone can just start a journal now, which is sort of a weird thing. Yeah, so let me post that up there. Where did I do it? There it is.
Right. So the final thing about what I want to say is, in February or so of 2022, I will send email to everyone who registered for this year and last year and ask for recommendations for people to be speakers. And I must say, in general, it's been more senior people. Maybe next year we'll start going down to more junior people, but we want to have people who are not going to talk about their just a small result from a conference paper, but talk about, you know, the work they've been doing for a few years. Sometimes we don't get that opportunity, and that's what we're supposed to do here. I'm also open for finding ways to make this more interactive. I really wish that instead of having things go across the chat, I could get together with a few people after this and we could, you know, have a conversation about the talk. So we might do some kind of mixed live remote thing next year. We'll see what we can pull together, but I can't beat the price of this. So yeah, GatherTown, I'm sorry, doesn't do it for me.
No.
No. It's better than nothing, but it doesn't do it completely for me. Anyway, thanks again. We're going to shut this down in a few minutes, and that's it.
Okay. Thanks.
Thanks.